10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Welcome to the European Spaceport in French Guiana and the launch of a very special satellite, Biomass, on a Vega-C rocket for the European Space Agency. It's going to study the world's forests using an incredible new radar to penetrate the canopy even through clouds.
Our satellite is in there, on the top of the Vega-C rocket, ready to start its journey into space.
For this YouTube Live, we will be here in the Jupiter Mission Control Center.
Right by your side to guide you through the operations. I'm Samuel Rogers.
I'm Katie Haswell, and welcome to flight number VV26. A very big welcome. We are live at the European Spaceport in French Guiana on the coast of the Amazon rainforest, and our rocket, Vega-C, is getting ready to transport a pioneering science mission to space, Biomass. It's going to analyse the condition of the world's forests, just like the one it's lifting off from, which is vital for tackling climate change. Now, we are 15 kilometres from that pad in the Mission Control Centre, the nerve centre of operations here, and I'm with Samuel Rogers in the commentary box. Samuel from Ariane Space, Head of Advanced Studies. Thanks ever so much for being with us, Samuel.
Thank you, Katie. Great to be here. Hi, all.
And if you want to ask a question and you're watching on YouTube, you can pop it into the chat box and Samuel will do his best to answer it later in the programme.
Correct.
Right, now let's go inside the control room to find out how operations are progressing. And the head of the flight desk is David Cavalloles, the CEO of Ariane Space. Thanks for being with us, David.
Hi, Katie. Good to be here with you today.
David, Ariane Space is operating the launch. So I just wonder, what does that actually mean?
Well, it's very simple. It means that we are responsible from the beginning to the end of making that launch happen. So concretely, it implies that we are working very closely with the client, hand in hand, to prepare the mission, typically to define together the best injection strategy for the satellite. Here in Kourou, we perform very important operations to prepare the satellite and to integrate it into the launcher. And of course, last but not least, we are accountable for the launch itself.
And how are things progressing today in the countdown?
Well, overall, the campaign went very smoothly, and I would like to thank the team sincerely for that. One of the key last milestone has been the rollback of the mobile gantry that protected the rocket, the Vega-C rocket. So now Vega-C is on its launch pad, ready for liftoff, and the launch should happen now less than 20 minutes from now.
Good to hear, and everything's green so far, so good. David, it's an important mission, isn't it? Can you tell us a little bit more about it?
Yeah, for sure. This is indeed a very important mission. The satellite we are launching today is called Biomass. This is a mission for the European Space Agency, which is our client today. And Biomass carries on board a very innovative payload, a radar that will watch the forest all around the world, and it will provide very useful data about the carbon cycle it will be very useful for our scientists, very useful for our decision makers as well. And through this mission, we'll contribute to fight against climate change and also to protect biodiversity. So for this reason, I'm extremely proud in the name of Arianespace to be launching Biomass today.
Great. Thank you very much indeed, David, and best of luck to you and all the teams. David Cavallolis, thank you.
Thank you.
Now, Vega-C and Biomass are due to lift off in just over 15 minutes' time. Samuel, what's going to happen after that?
Yeah, so as you said, the liftoff will be triggered by the ignition of the first stage, which we call P120, the first stage of Vega-C. It will push for about 2 minutes and 25 seconds, and then a separation command will be sent to separate it. It will then be followed by the ignition of the second stage, the Zefiro 40, which will continue increasing the launcher speed for about 2 minutes. Then this stage will be separated as well, and it will be the Zefiro 9, the third stage, that will take the relay and provide the launcher thrust. Zefiro 9 will push for 2 minutes and a half, and during this phase we'll separate the fairing, which was protecting the satellite as we went through the atmosphere. Then the Zefiro 9 stage will be separated, and we'll have another important step, the ignition of the upper stage, the Avum Plus, which is a bit different because it uses liquid propellants. After 7.5 minutes, we will shut it down, and then we'll have what we call a ballistic phase, a long phase over the North Pole, and then back down to Australia, where we'll be in contact with a ground station in New Norcia to perform the second ignition of the upper stage. And as we'll have reached the final required orbit, we will be ready to separate our passenger today, Biomass. Then we'll have another ballistic phase over the South Pole before reaching the last step of this VV26 mission, which will be the third ignition of the upper stage over Cuba. This is necessary to make the upper stage re-entry, and this is very key to avoid leaving any debris orbiting the Earth.
Meanwhile, Biomass will be coming alive, ready to start its job, and what an important job it is. It's going to scan the tropical forests just like a doctor to help scientists understand what state they're in and their role in the carbon cycle. And to do that, it has a very pioneering radar which can see right down inside even the thickest of forests to analyse the trunks, the branches and the large shoots, which is where the trees store their carbon. It's going to help us to understand our forests. It's very important. Let's take a closer look.
For thousands of years, forests have acted as the lungs of our planet, absorbing carbon dioxide, releasing oxygen, and sheltering an incredible variety of life. However, deforestation, climate change and human activity are changing these essential ecosystems at an alarming rate. So how can we accurately gauge the extent of organic matter stored in our forests? The answer lies above us, in the silent, watchful gaze of a satellite. Introducing Biomass, a revolutionary Earth observation mission set to change the way we see and study the world's forests. Biomass is part of the European Space Agency's Earth Explorers program, pioneering scientific missions designed to deepen our understanding of Earth's complex systems. Today, from Europe's Spaceport in Kourou, Biomass will embark on its journey aboard Vega-C. Weighing 1,250 kilos, this cutting-edge satellite will be placed in a sun-synchronous orbit, 670 kilometers above Earth. Its mission? To deliver the most accurate map of biomass distribution in Earth's forests. Equipped with a fully polarimetric P-band radar and a massive 12-meter diameter reflector, Biomass is the first satellite ever to carry a radar instrument capable of penetrating dense forest canopies to collect information on tree trunks and branches, where the majority of carbon is stored. Forests are among our strongest allies in our efforts to mitigate climate change. They store vast amounts of carbon, but the exact quantities remain uncertain. Rising temperatures, increasing CO2 levels, and expanding human activities are reshaping forests in ways we still don't fully understand. Biomass will provide the first ever global estimates of forest biomass and height. Over its 5-year mission, Biomass will systematically scan the entire globe every 9 months, delivering crucial data on forest structure, biomass distribution, and above-ground carbon storage. This is the missing piece scientists and foresters have long sought to improve climate projections. Governments, conservationists, and researchers will have access to reliable and consistent forest data, enabling them to make informed decisions that shape the future of our planet. By unveiling the unseen, biomass serves as a storyteller for our forests, a beacon of knowledge in the pursuit of a more sustainable future. Because to protect our environment, we must first understand it.
Indeed, and that need to understand how Earth works as a system and how people are affecting natural processes is more urgent than ever. And Biomass is the 7th satellite in the European Space Agency's Earth Explorer science program to do just that.
Yes, indeed. And in fact, the Earth Explorer satellites actually collect information about all the complex processes of our planet. We can have several examples, typically the motions of the winds or the tides, or measure the thickness of the polar ice caps, or monitor the magnetic field of the Earth. These are typical examples of the missions they are carrying.
And many more. Very, very important program. Just back to our launch, we've had our final weather check. That was at T-10.
Yes, indeed, and the news were good. Actually, we had another check before the removal of the mobile gantry, which we see on the screen just behind the rocket. It was 4 hours before the liftoff to check that everything was fine before removing it. And the last weather check, as you mentioned, was 1 minute ago, and the news were good, so all is fine for lifting off.
Looks like we have a slightly cloudy sky here, but the weather's actually been rather nice these last few days. We've had a bit of sunshine. I can see there on the image the clouds might just part for us for a beautiful launch, and of course sunrise. The European Space Agency teams who will be operating Biomass are standing by in the mission control room at the European Space Operations Centre in Darmstadt in Germany. Just over an hour ago, the Flight Operations Director Jose Morales took the roll call.
All positions on the briefing loop. This is the Biomass roll call. All positions shall report on this loop to me by quoting your call sign followed by go or no go. Some go. AOCS.
AOCS go.
Data handling.
Data handling go.
Power.
Power go.
Spacon.
Spacon go.
Timeline.
Timeline go.
Project rep.
Project rep go.
PST lead. Software coordinator.
Software go.
Software support.
Software support go.
Flight dynamics.
Flight dynamics go.
OM.
OM go.
S-track.
S-track go.
Scheduling.
Scheduling go.
Excellent. This completes the Biomass roll call.
Excellent. So they are go for launch. We are go for launch. The boards are green, and we are 6 minutes and 56 seconds and counting to liftoff. We'll check in again with the ESOC teams after launch, and especially when Biomass will send its first signal home to spacecraft controllers. Back here at the Guiana Space Centre, we've got several control rooms. Obviously, this is mission control, but we've got another control room, Samuel. It's launch control, we call it.
Yeah, launch control center. It's if we compare the rocket with an airplane, then the launch control center is a bit like the cockpit of this airplane or the rocket, if you wish. So, and here we can see the team on the screen. They are in charge of preparing the rocket for the last step, checking the parameters, overseeing all these final operations to get the rocket ready for the launch. And of course, once the liftoff will be triggered, the rocket is fully autonomous. It goes autopilot after the liftoff. And in fact, you have two teams. The first one we saw are actually running the operations, and the one behind are checking that the actual parameters are in line with the expectations and checking if any deviation, then analyzing the situation.
Laser focus at this point as we get closer and closer now to the launch. Vega-C standing tall on its pad. Now everyone also has their eyes on the status panels. We saw them earlier here in the Mission Control Center, the green panels. There they are on the left-hand side of the screen there.
Yeah.
All green at the moment, good sign.
It's a bit like the traffic lights. If it's green, we can go ahead. If it's red, of course, we'd better stop and analyze. And each of these panels actually corresponds to a person, a team operating or monitoring that system. Could be, for instance, one for the rocket, of course, checking for instance, the tank's pressure or temperatures on board, the status of the onboard computer. Of course, we check also the communication links, the weather status, as we mentioned before, but for sure also the passenger Biomass, which has its own status panel, which is on the screen. And of course, if something goes wrong, if there is any parameter that deviates from should be the nominal value, then we notify the range operation manager, and we can hold the countdown time needed to analyze the situation and then assess what the next step should be.
Coming up now to the beginning of what we call the automatic sequence or the synchronized sequence. That's the last 4 minutes. Coming up, just briefly, Samuel, what is that?
À tous de DDO. Attention pour la séquence finale lanceur.
Range Operations Manager Jean-Frédéric Alassatadé getting ready to announce it.
Top H0 4 minutes.
So what is the synchronized sequence?
During this sequence, in fact, the rocket is becoming progressively autonomous. So currently the computers are managing an impressive sequence of complex operations, each of them timed to the millisecond to get progressively the full autonomy to the launcher.
Now, the job of preparing the rocket and the spacecraft here at the Spaceport started a couple of months ago. We call this process the launch campaign, and the teams have been working extremely hard during that time to get everything ready for today. Our cameras were there. Samuel, what's been happening?
So first, most of the parts of the Vega-C launcher arrived actually by sea, as you can see, at the port of Kourou, and were then transported by road to the Space Center. The rocket is assembled step by step from several parts, which we call stages. Here you see the first stage, P120 booster, transported to the launch pad, and then we have the second stage here, which was hoisted and then assembled on the top of the first stage. The third stage, the Zefiro 9, is also lifted into the gantry and integrated on top of the two first stages. Then it was the upper stage, the Avon Plus, which arrived in its dedicated container. You can see it there. It's hoisted, unloaded, and then integrated onto the first stages. As for the satellite, Biomass arrived in French Guiana on the 7th of March, also by boat. A number of operations were carried out in autonomy for Biomass. Then it was filled with propellants, and you will see the special suits that we use for this operation. Here you see it on the movie. Then it was integrated on what we call the adapter, which is the structure which make the link between the satellite and the launcher. This is the black cone you see on the screen. And then it was enveloped in the fairing, this huge part you see, and what we call the upper composite was then transferred into the launch pad. It was hoisted on the very top of the launcher and then integrated on the upper stage finally we have, as we said, removed the gantry and we have the launcher ready for liftoff.
Indeed, and here we are, 1 minute and 31 seconds now to launch, hoping for a very beautiful dawn launch. Getting close, quite tense at this moment before launch, isn't it?
Yeah, we can clearly feel the intensity, the concentration, all the teams are focused on their task.
À tous de DDO. Attention pour moins 1 minute.
Coming up to 1 minute now to launch.
Top H0 moins 1 minute.
We are live at the European Spaceport in French Guiana, getting ready now for the launch of Biomass for the European Space Agency. Good luck, everybody.
Good luck.
À tous de DDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage P120. Décollage. Propulseur nominal. Début du basculement. Propulsion nominale. Pilotage calme. Trajectoire nominale. Acquisition Saint-Jean. Trajectoire toujours nominale.
Sunrise over the Amazon rainforest, and Biomass has started its journey, blazing a trail on
La
board the
trajectoire est
Vega-C
nominale, le
rocket
pilotage est calme.
on its quest to understand forests just like the one it's lifted off from, on its mission for Earth and for our future. We can hear it flying over the...
Amazing pictures, and yeah, we can feel the walls
shaking here at the Jupiter Mission Control
Trajectoire
Center.
nominale.
He's telling us that everything is going well.
Yeah, so far it's perfect. We are lucky to see it so long. It's given the clouds we had at the beginning.
Getting some great views here from our cameras. Nice. Burning the P120 first stage here, which is getting us away from the
La trajectoire est nominale, le pilotage est calme.
The gravity of our planet. The range operations manager there telling us that the trajectory is nominal and the pilotage, the piloting.
Yeah, control of the thrust, the orientation of the thrust as well. So it's nominal means everything's fine.
Good. Coming up
Début côte poussée.
on the separation of the P120 will be the first event.
La trajectoire est nominale.
Everything's going according to plan. Fantastic views.
Potentially we could see it from the cameras. It could be nice, yeah. Should occur in a few seconds now.
Indeed, this is the scheduled moment for the separation.
You can see it on
Séparation P120.
and it's just confirmed.
Allumage Z40.
So he's just confirmed that we've separated the
La pression est
P120,
nominale. La
first
trajectoire est nominale.
stage. We've switched on the second stage, the Z40. Everything's going normally. And Z, what does that stand
Z
for?
is for, yeah, Zephyro. It's an Italian name for a type of wind. Because I guess it's a bit windy when you're on
Trajectoire du
board
lanceur nominale.
such a booster.
Look at that. Fantastic. We're seeing it. We're 3 minutes and 11 seconds into the launch, and we can still see it with our cameras, which is very exciting. So we've got clear skies here at the Guiana Space Center.
Amazing, yeah. Wow.
We had several weeks of rain and suddenly it's been very clear
La
and
trajectoire
beautiful.
du lanceur est nominale.
He's telling us that the trajectory of the rocket is normal.
It's perfectly as planned. Yeah.
And of course the fairing, which is where our satellite is encapsulated at this point, Samuel, is the nose cone, if you like. We saw it before
La
the
trajectoire est
launch.
nominale, le pilotage est calme.
And
It has a multiple.
it's got a number of jobs, hasn't it?
Yeah, exactly. Yeah. It basically protects biomass from a number of environments. First, of course, the Guiana environment, the rain and the dust, everything. But also at liftoff, we have, when we fire the booster, there is quite a high acoustic vibration environment. Then the fairing is used to damp it, and as well to.
Trajectoire nominale, pilotage calme.
As we go through the atmosphere, it helps reducing the heat load generated by the friction with the atmosphere or the vibration. So it's quite a clever piece of hardware, yeah.
Very important. You can see it at the front of the rocket there, the sort of bulbous section. Right, we have now the scheduled moment to separate the Z40 to jettison that.
Séparation Z40.
That's
so we
been
just confirmation that the Zephyro 40 stage has been separated.
and
Allumage Z9.
And
we've switched on the engine of the Z9, and we've also waiting for
Propulsion
confirmation
nominale.
of the fairing jettisoning.
Séparation des coiffes.
And we have
we have
confirmation.
it. Yeah.
So we can see our satellite for the first time, Samuel. Why don't you explain to people what we're looking at here on these computer-generated images?
Yeah, on the left of the screen, you can see on the right,
Trajectoire
biomass
nominale.
passenger with, of course, its radar and solar panel folded. It's attached to what remains of the launcher, which is rather small as compared to what was on the pad, through the adapter, this black cone, and then you have the upper stage, which is a tiny, a slice, a white slice of the launcher, and on the
La
left,
trajectoire du lanceur est nominale.
the Zephyro 9 stage, which is still thrusting our passenger into space.
And of course, once biomass is separated from the mothership, it'll unfold its solar wing. It has one solar wing made up of 4 solar panels. And of course, it's amazing, great big reflector, which looks like a huge space umbrella.
Yeah.
So quickly, let's just explain to people what we're looking at on the screen. So we've got the 3D images, which are computer generated.
Yeah, and they correspond to the plan.
La pression chambre est nominale, la trajectoire est nominale.
It illustrates what the launcher plus biomass behavior should be in space, the orientation towards the sun or towards the earth, for instance. Of course, the altitude, the different stages separation, as we saw, and of course the real orientation and firing as we see here.
You can see on the left side of the screen are the various events that as they happen, and then on the right hand side of the screen the trajectory, and we also have the altitude. At the moment we're 663 kilometers
Trajectoire
high.
nominale, pilotage
263.
calme.
Yeah.
Sorry, it's 263.
Yeah.
We will be getting closer
Exactly.
to 600
Not
later.
yet.
And our distance is our distance from the pad. If you were to draw a straight line across our planet, and look at that speed, we are travelling, Samuel, at 7.53 kilometers per second.
This is quite fast, yeah. This is roughly, 8 kilometers per second, just for people to have an idea, is 30 times the velocity of a commercial aircraft. So it's fast.
Séparation Z9 confirmée.
About 28,000 miles per kilometers per second.
Per hour. And here we had just confirmation of the separation of the third stage, the Zephyro 9.
Indeed. And we can
Acquisition de
see
la télémesure par la station Bermude.
there he's announcing that we're picking up the signal at the Bermuda tracking station, which you can see there on the globe. Bermuda, of course, in the northern Caribbean.
Orbite du Z9 correct.
I'm sure it's all very sunny as the sun rises there. Very pleasant weather, I'm sure. Checking in there at Bermuda and saying hello to the teams. So our flight path takes us, north, up over the North Pole?
Exactly, yeah. We'll fly after the Canada, we'll fly over the Arctic, and then back down over Southeast Asia and to the west coast of Australia, where we will separate biomass.
Début de la manœuvre d'orientation pour le premier boost à Vaume.
So he's saying we are orienting doing a set of maneuvers to orient correctly the launcher to fire the upstage Avon Plus, which should occur in a second or two.
Allumage de l'AVOM.
So we have confirmation that the Avon Plus upper stage has switched its engine on, and that's an important moment, an important milestone. We've really now started the next phase of the journey, because the
Propulsion
Avon
nominale de
Plus
l'AVOM.
is a little bit like our orbital taxi driver. Its job is to deliver our passenger to its drop-off point in space, and that's a very important job.
Yes, indeed, and it's the Avon Plus job, as you said, to deliver biomass exactly on the right orbit, in the correct orientation, and to do that we need to perform with this upper stage precise set of maneuvers, and we'll see two
Fin de la
firings.
poursuite Saint-Jean.
This is the first firing, and we'll have another one later in the mission, and this will enable to reach the separation orbit, which
Propulsion du lanceur nominal, pilotage calme.
is circular at 670 kilometer altitude in about 49 minutes.
Fin de visibilité Galio. Trajectoire nominale, propulsion nominale.
So we've gone out of the range of the Galileo tracking station. That was the tracking station here at the spaceport, and everything's going well. Big space projects like Biomass involve hundreds, sometimes thousands of people pulling together to make them happen. They involve brain power, teamwork, lots of problem-solving skills.
And potentially lots of coffee cups as well, or tea.
Lots of cups of tea in this case, yes, because Biomass has been designed, built and tested by the European aerospace giant Airbus Defence and Space, and all of that's been done in the UK.
And they are what we call prime contractor, so it's like they are conductor of an orchestra.
Propulsion nominale de l'AVOM, pilotage calme.
It means they manage a group of companies and suppliers. Each of them play a super important role, and we have many industrial teams from Europe, but as well from US or Canada, which were involved in delivering hardware for Biomass. And in particular, as you mentioned, the satellite platform was assembled in the UK, indeed.
In fact, I was lucky enough to see it because I was filming there a little while back, and it was really exciting to see Biomass in the clean rooms taking shape. Big shout out actually to my fellow compatriots in the UK, Airbus in Stevenage. So let's just check where we are in the flight. We are climbing.
Close to 300 kilometer altitude and 3,000 kilometers.
La trajectoire de l'AVOM est nominale.
So trajectory is perfectly on the target. We are running gently the propulsion of the Avon Plus, consuming propellants.
And we're coming closer now to picking up the signal at the Gatineau tracking station. You can see it there in Canada, the northeastern coast of Canada.
Acquisition de la télémesure par la station Gatineau.
He's just confirmed that we've picked up the signal there. It's a bit like a relay race, isn't it?
Exactly, yeah.
Handing the baton from one tracking station to another.
Yeah, we want to be sure to have contact with the launcher during this phase while propulsion is active to receive the parameters.
Pression nominale des réservoirs, le pilotage est calme, la trajectoire est nominale.
Everything's going normally. So the rocket's talking to us, it's sending its signal back down to the tracking stations, and they then transfer that information to the telemetry team here at the spaceport. We call them the CVI in French, or the Quick Look Telemetry Team. And we can see them actually in the bottom right of the screen there. Our colleagues, your colleagues there, Samuel. They're on a hilltop, aren't they, just outside the spaceport?
Yeah, very close to the spaceport, on La Montagne des Pères. And they are actually, as you said, receiving the major flight parameters from the launcher.
Nominale de l'AVOM.
All along the flight, thanks to these antennas, which are located on the.
Il reste 3 minutes de propulsion de l'AVOM.
On the path, and it's a bit like the doctors who are checking the health, monitoring what's happening on board, checking everything's fine, as expected. And you can see here my colleagues Michael Krebel, who is in charge of the team, and also Armel Giral, together with Avio and CNES colleagues. And this is, as we said, possible thanks to the different ground tracking stations located first were in French Guiana, then in Bermuda, then in Canada, and last one will be in Australia, as we mentioned.
Now one of the features of the Avon Plus upper stage is that it can restart its engine again and again. We have another team here in the Colifero in Italy.
Yeah, indeed. There are teams from Avio, the rocket manufacturer, and they are checking from Italy that the launcher behavior is fine, analyzing the data.
Pas d'écart en altitude, trajectoire nominale.
There are people from different teams, such as propulsion, structure, control,
Le lanceur est mis sur orbite.
and they are available and ready to jump if needed as a support team, so it's very useful.
And indeed, as you say, they are the manufacturers of the rockets, so it's very useful to have them there and to have as many people on the job as possible. Indeed, as I was saying, one of the features of the upper stage is that it can switch its engine on and off, and that's actually very important. Why is that?
Yeah, it's very key because it's a major asset of this upper stage, because it makes possible to take different passengers, like you say,
Pas d'écart en altitude, la trajectoire est nominale.
Like a space bus, to put different passengers to different orbits, but in the same launch. So this is really key, and with this upper stage Avon Plus, we can fire it up to 8 times, and this is much more than the previous 5 on little sister Vega, and so it's very helpful to deliver several satellites on typically 3 different orbits we can reach with Vega-C.
1 minute de propulsion de l'Avon.
On the same
La
mission.
propulsion est nominale, trajectoire nominale.
So it's really a key asset for our customers indeed.
And it means that you can take pretty well any satellite to any orbit, and that's very important, that level of flexibility.
Yeah.
And we're getting ready now, the Avon upper stage is getting ready to switch off its engine. How does it know when to switch it off?
In fact, this is based on its initial position, which we feed the launcher with on the pad, and then it has clever instruments along the flight, computing where it is and how it's oriented, what's its velocity all along the flight.
Propulsion nominale, pilotage calme.
It knows precisely where it is and when to stop it, and which should occur soon.
We are 329
Fin de la
kilometers
visibilité par la station Bermude.
above our planet. We have now gone out of range of the Bermuda tracking station, and we're being tracked by Gatineau, getting ready to switch the engine off.
Propulsion nominale, pilotage calme.
For the confirmation
Extinction
there.
de l'étage avant.
And we have the switch off of the upper stage engine now confirmed, so that's really good. Why now? Why do we switch it off now?
Par l'étage avant correct.
So it's just saying that when we stopped the engine, as I was saying, we were exactly on the point we wanted to be. So this is really a good news. And why do we stop it? We stop it because we are climbing to just below 700 kilometers, and we'll do it in 2 steps. So here, this is the first step, and we have reached the target.
La pression des réservoirs est nominale.
So we just stop it, and it's all very normal as planned.
Now, today's launch is the result of years of collaboration across many, many teams, and we've been talking to some of them. Let's hear from them now.
Je suis chef de mission Ariane Espace pour la campagne de lancement de Biomass, un satellite scientifique de l'Agence spatiale européenne.
At ESA, we are the system architects of the mission. That means that me and my team, we are responsible that the satellite is being built, that the algorithms for data processing are there, and finally that we have a launcher.
La responsabile di campagna ha il compito, conoscendo tutto il sistema e avendo una visione un po' di tutto il sistema, ha il compito di identificare eventuali impatti e a gestire la riprogrammazione delle varie attività.
Lo importante para poder desarrollar y construir un satélite es la gente, es lo más importante, y además tener un buen equipo. En Biomass todo el mundo ha estado involucrado desde el principio y me parece que tenemos un buen equipo de AIT y de diseño.
Chaque lancement est spécifique, chaque campagne de lancement est spécifique. Donc toutes ces spécificités doivent être prises en compte par le chef de mission dans son planning de préparation. Il faut évidemment faire preuve d'une adaptabilité importante, tant au niveau technique qu'au niveau relation avec les différents industriels. Donc il est important de les écouter et de bien leur faire comprendre toutes nos spécificités pour que la campagne de lancement se passe au mieux et que la chronologie de lancement se passe également au mieux.
Le giornate di campagna non sono mai tutte uguali, sono molto diverse l'una dall'altra, ci sono sicuramente degli appuntamenti che sono sempre gli stessi, sono dei momenti di confronto tra tutti i team di campagna e sono dei momenti ai quali non si può rinunciare, a cui devo partecipare.
Durante el lanzamiento nosotros los eléctricos vamos a estar justamente aquí detrás encendiendo el satélite por última vez. Y me han dado el gran honor de poder ser la última persona en encenderlo y además durante las últimas 30 segundos vamos a poder ver que todo funciona perfectamente.
Biomass is a science mission, an Earth science mission. It is an instrument that has never been flown before. Therefore, we had to face a lot of technological problems in its development. We were also hindered by the fact that we were in the middle of the COVID crisis when the most people should have been in the laboratories. And finally, to mention as a challenge is that the instrument cannot be tested on ground and we have to rely on tests and analysis, and we will only see the final outcome once we are in orbit.
À Jupiter 2, à côté du DDO, on est là pour la coordination globale. Le DDO s'occupe de la partie
de la station Gatineau.
La base de lancement avec
le trou TM attendu est d'environ 32 minutes et 25 secondes.
Et le chef de mission est à côté de lui pour lui transmettre toutes les informations venant de la charge utile, donc du satellite, et toutes les contraintes qu'ils amènent évidemment pour aller jusqu'au lancement.
Good to hear from the teams there. Now, once the upper stage delivers biomass onto its orbit, the teams at the European Space Operations Centre, which is in Darmstadt in Germany, will take charge of flying their satellite.
Yeah, and first biomass should call home, then it will unfold its solar wing and start all the process of being tested before actually it can begin its job of scanning our forests, which should start in 6 months from now.
Indeed. And the teams at ESOC operate all the European Space Agency's satellites. That's more than 90 of them over the years. And they also take care of ESA's network of tracking stations. They provide world-class expertise for flight dynamics and mission operations. And it's also home to ESA's space safety program. So it's a busy old place. Thomas Ormiston is a spacecraft operations engineer, part of the team flying the satellite, so he's one of the people in charge of flying biomass today. Let's go to Thomas now.
And hello, welcome to Mission Control here in Darmstadt, Germany, where the team are calm, sitting back, enjoying the ride for the time being as we carry on the journey of biomass to space. They're all getting ready for that moment we're hoping for a bit later on, where we'll pick up the signal. But for now, we can enjoy standing here, and I'm here very happy to be joined by biomass mission scientist Bjorn Roman, who's going to tell us a little bit more about what biomass is going to do. So thank you, Bjorn, for being here. It's your baby. How are you feeling having seen that spectacular sight?
Yeah, spectacular launch, Thomas. It was great to see it from here. We're also joined here by a lot of people from the science team. We've been waiting for this for years, and of course waiting now for the spectacular things that are to come after the launch.
Absolutely, and I saw the emotions on people. It's quite a moment here, and there's still more moments to come. Now, tell us a bit more about this. One of the key goals of biomass is to study the role that forest biomass plays in the carbon cycle. How is the data from the mission going to help fill in humanity's understanding of this?
Yes, Thomas. A very good question. The main science question of the biomass mission is really to try to unravel the main unknowns that we have in the global carbon cycle. As people know, most of the actual CO2 emissions that are going up in the atmosphere are coming from the burning of fossil fuels, but the remaining part is coming from land use change, and most of it can be attributed to deforestation. And this is and on the other side, there's of course as well then the actual sinks. About half of it, what we're actually emitting, remains remains in the atmosphere. About 3/10 is going back into the forest. So this is actually a very good thing. This is actually one of the few things where forests are known for, is that actually there's a very natural way of capturing carbon. And actually the forests are growing from it. So it's actually a very, very nice thing. The remaining part is going into the ocean. And for the oceans, actually, it's kind of a bad thing. You get an acidification of the oceans, which is really detrimental for the ecosystems and biodiversity. On top of this, the biomass mission will especially look at the tropical forests. And this is exactly the areas where the largest unknown, so we have a gap in our knowledge. And on top of this, there's also the place where we know the largest changes are occurring.
Yeah, exactly. And I mean, when we're looking at those things, I mean, we've had radar missions from ESA before. These are studied in other ways. I mean, what is it about Biomass's radar that makes the technology so unique and so special for this?
Yes, I can tell you about this, Thomas. So as you mentioned, ESA has been flying radar missions before, and the type of mission that we're flying, type of technology, synthetic aperture radar, we're flying this actually already since 1991, ever since the launch of ERS-1. So SAR is not new to us, but what is new to us is especially the frequency that we're flying. We're flying for now with Biomass. We're flying the lowest frequency used for Earth observation for radar imaging ever used by mankind. So this is a really unique, and with this wavelength, we're able to actually penetrate down to actually the forest and down to all types of natural media, which would give us additional new information, complete new information on our planet. And in the forest, we're able to we're actually sensitive to the larger structures that we see in the forest. So think about the branches and the stems, and this way we can get, let's say, really new information that we can then later on relate to forest biomass and forest height.
Excellent, amazing. And I mean, I understand these forest ecosystems are incredibly diverse and varied. I mean, Biomass, I think, will allow scientists to differentiate between the different types of forest to measure the biomass. I mean, how's it going to do that? Yes,
this is a very intricate process with a lot of very interesting algorithms that we're going to do. The first thing, of course, we get the data from the satellite, and with this, we hope to be able to estimate biomass, but as well forest height. Together with these two, we hope to be able to constrain our solution space in the end. What we have on top of this with Biomass is that we have a very exciting first operational phase of the mission where we employ tomography. And it's actually the first time where we systematically employ this type of operations during a mission. And with the tomography, which you can compare like with a CT scan when you have to go to hospital. Hopefully you will never have to see this type of device, but it's able, let's say, to slice 3D slices of the human body. And we're doing something similar in the forest. So we get information on the 3D structure in the forest, so we get a 3D view on what is happening there. And with this, we hope to get as well additional structural information that we can relate to different forest species, different forest biomes.
Wow. Really fascinating. And I mean, yes, so Biomass is one of our Earth Explorers. The Earth Explorers all have a topic, and Biomass is focused very much on forests. But are there other areas you expect this mission to contribute to?
Yes, for sure. We're actually counting on it. This will be, as I mentioned, is the first time we're going to fly P-band, this 435 megahertz frequency. And with this, of course, we're going to basically, for the first time, look at our planet with what I call P-band goggles. So we really are going to unravel completely new things about our planet. And this is always when you fly something new with a new wavelength, you will see completely new things. But we have already identified a few areas for which we know there's a good chance that we can do some real nice new science. One of them is looking at the forest floor. As I already mentioned, that we're going down with a signal, we're able to penetrate down to the entire forest layer. And we're actually also sensitive to information that we get from the forest floor. Now, with other systems, we always get to say out at the top of the canopy a bit, but we never can create, let's say, a digital terrain model from the forest floor. And about 30% of the land is covered by forest. So all the DTMs that we have, the terrain models and the digital elevation models, they have a kind of an unknown area. They are not able to precise accurately what actually topography is doing there. So this is something that we hope the mission will also be able to contribute to. A second one is we're looking at ice in the Antarctic, the land ice in the Antarctic, and how it is actually moving. So there are all missions that are doing the same thing, but because again above our penetration into the ice, we'll be able to get access to additional volume scattering that hopefully is going to be stable over time to be able to follow this as well. In addition as well to ice structural information. Then another one that's also very exciting is actually that we're able to look at the deserts and look at paleohydrology. So looking at ancient rivers been dried up, and maybe some remains of ancient civilization that were living in deserts at the time they were not deserts. So this will be, and of course, Thomas, this is not everything. There's going to be for sure, as I said, looking with P-band at the planet, we're going to be in for some surprises there.
Wow. I mean, really, really exciting stuff. And yeah, I think we can all be very, very excited about the science surprises. I would say, though, as an operations person here in this room, we don't like surprises. We hope everything goes according to plan. So far, indeed, everything is good. You can see on the board behind me that we're all green. ESOC is very much ready to take control of the spacecraft when it separates not long from now from the upper stage of that Vega-C launcher. But for now, I would like to say thank you very much to our launcher for giving us a gentle ride. We will continue enjoying it here in the control room, and we will be back to talk to you later once we've separated to catch that all-important moment of first acquisition of signal. Thank you very much. Back to Katie.
Thank you so much, Thomas and Bjorn. So great to hear from you both and have such a fantastic description of this terribly, terribly important satellite. Okay, so we're going to take a break now because we're coasting without the engine. So we're going to cut our mics for 20 minutes. We're coming back at 7:05 Kourou time. That's 11:05 here in UCT, Universal Time, 12:05 in Paris. And if anyone wants to ask a question,
put them in the chat.
Yeah, put them in the chat box on YouTube or any of the social media. I think you'll do your best to answer later. Okay, see you in 20 minutes. Bye.
Goodbye.
À tous dans le CDC. Donc on approche de l'acquisition Nunorcia. Merci de baisser un peu le volume.
Hello again and welcome back to our YouTube Live. We're coming to you from the European Spaceport in South America. We are 51 minutes into the launch of Biomass for the European Space Agency, and those images were the launch, which took place 51 minutes ago. We lifted off from the pad here at the Spaceport, and right now Biomass, our very precious satellite, is hurtling through space, attached to what's left of the upper stage. I'm Katie Haswell, and joining me in the commentary box is Samuel Rogers. Samuel, great to have you with us. Thank you.
Thank you. Great to be back.
Yeah, Samuel is a real rocket science expert. We're very lucky to have him in the commentary box. Samuel, just run through what's happened for anyone who missed the beginning.
So we had the first phases of the flight were first the ignition
Acquisition de la télémesure par la station Nunorcia en Australie.
He's just letting us know that we've picked up the signal at the new Norcia tracking station in Australia, so we're checking in with the teams there.
So we had main steps were first stage burning,
Le
so
pilotage est calme
P120.
de l'étage avant.
Then we had the second stage, Zefiro 40, for a bit more than 2 minutes, then the Zefiro 9 for 2 minutes and a half, and then the first boost of the Avon Plus upper stage over Canada, and we had a long pause over the North Pole without propulsion, and then we have just had contact with the New Norcia ground tracking station and will be ready soon to fire the Avon Plus again for the second time.
You can see on the left-hand side those events, what's coming up and what's already happened, what's happened in blue, what's coming up in white, and our telemetry on the right-hand side of the screen. We've got some hot news from the Guiana Space Centre. The team's tested a new solid propellant rocket motor called the P160. That was a few days ago.
Yes, indeed, and it's a major milestone.
Début de la manœuvre d'orientation pour le deuxième boost à Vom.
I will interrupt while he is speaking. It's a major milestone because it's a key development for future upgrades
de la manœuvre d'orientation.
Of both Ariane 6 and Vega Europe's launchers. This new motor is 1 meter longer than the P120, and it carries 14 tons additional propellant.
And we've got here the switching on of the upper stage, which has now been confirmed. And here's the picture. We can actually see the hot fire test there of the P160 firing up.
And it's really key because it will increase the Ariane 6 and Vega performance, their payload capacity and their competitiveness. So really a very good complementary development for these.
Trajectoire du lanceur nominale.
He's telling us that the trajectory is normal, everything's going according to plan up there in space. We've had a question from somebody called X who is asking Samuel, why does the fourth stage burn for so long? Is it in orbit yet?
So yeah, we are in orbit, but not at the right altitude. So we are, in fact, we are like in a roller coaster. So first we have picked up some speed thanks to the solid boosters.
En altitude, pression chambre nominale, trajectoire nominale.
Thanks to the solid boosters and the first Avon burn, then for the first 16 minutes of the mission. And then at the end of this first boost, we were at the bottom of the roller coaster, starting moving up. And during the break, we have slowly lost speed, but we moved up to higher altitudes. And in physical terms, it means we have transformed the kinetic energy, meaning the speed, in potential energy, meaning altitude. So now we are close to reach the top of the roller coaster at 670 kilometer altitude. So it's the right time to fire again the upper stage. So in other words, we were in an elliptical orbit and we're waiting to get to the apogee. This is the highest altitude point, to burn again the upper stage and circularize the orbit. This is the technical term for it.
So it's a bit like we were on the top of the roller coaster and instead of coming back down, we just keep on flying.
Exactly, flat.
Slightly terrifying concept.
Extinction de la Vom.
We've had the confirmation there that we've switched off the Avon Plus upper stage, so that's good news. Another very important moment. So as you say, we're on altitude.
And this is precise, very important information. The orbit
Début de la manœuvre d'orientation au profit de Biomass.
We have just reached is the right one. So now we're performing quite a set of maneuvers to orient the satellite plus what remains from the launcher to point the satellite into the right direction, the one required by the customer for biomass separation. So it'll take 1.5 minutes and then we'll be able to separate biomass by releasing the clamp band which was attaching the spacecraft to the black cone here, and then there are a number of springs that will gently push biomass away from the launcher.
We're effectively going to ping it into orbit so that it'll move away from the mothership. That's coming up in less than 30 seconds now. Very precise orientation maneuvers up there in space. These computer-generated images showing us exactly what's been planned for today's mission.
Fin de la manœuvre d'orientation.
So we have reached the end of the maneuver.
So we're getting ready now to separate biomass.
Séparation biomasse.
Nice.
Merci d'attendre.
Confirmation there that we have separated the biomass satellite. This is wonderful news.
Great news.
Congratulations to all the teams, everybody involved.
Nous attendons la confirmation de l'acquisition du signal du satellite.
He says we are now waiting for the confirmation of the acquisition of the signal of the satellite. That is, of course, when the satellite will talk to us.
Say this, yeah, hello.
And say hello. It'll call home to the teams at the European Space Operations Centre who have now taken on their new baby. And we're hoping to hear now from the CEO of Arianespace again, David Cavayolis, who spoke with us earlier. And look at those wonderful images there, the computer-generated images, the CGI animation of biomass. It looks like it's floating away, but it's actually travelling incredibly fast still, isn't it? It was 28,000 kilometres a second.
It's fast with respect to the ground, but it's slow with respect to the launcher. We want the separation to be gentle, not to have too high speeds to avoid any risk of collision. So it seems to be slow, but it's really fast with respect to the ground.
Teams here in the Mission Control Centre, everyone very, very delighted now that we've had the separation. So let's go over now to David Cavayolis, who joins us once again from the fishbowl. David, thanks ever so much for coming to talk to us. So good news.
Yeah, absolutely, Katie. I'm absolutely delighted to announce that today the Vega-C launcher, operated by Arianespace, has successfully placed into orbit its passenger, the Biomass satellite. I would like to very sincerely thank our client and partners, the European Space Agency. And today, with this launch, not only we reinforce the autonomous access to space for Europe, but also we contribute to make better life on Earth and to protect biodiversity. So this is really a huge achievement, and I would like to say a big congratulations to all the team involved, and thank you very much, and thank you to all our viewers all around the world.
Indeed, and it's a busy time here at the Spaceport,
de la manœuvre
isn't it, David?
d'orientation
Lots
de la
of
roue,
launches.
les pressions sont correctes dans les réservoirs.
So, David, thank you very much indeed for coming to the floor and chatting with us. We wish you and the teams the very best of luck now for ongoing operations. David Cavayolis, thank you very much.
Thank you.
So, good news, Samuel, for good news there. We've separated our satellite, and we're now waiting for the Biomass satellite to call home and talk to us. And this is going to take a little while because we have to wait for the satellite to come over the horizon, I believe, and for the spacecraft controllers at the European Space Operations Centre, which is the European Space Agency's Operations Centre, their mission control, where they fly the satellites. Waiting to hear from them later in the programme. But first of all, I'm absolutely delighted. I've got somebody very special joining me here in the commentary box. She is the principal investigator, one of two principal investigators for the mission. Her name is Thuy Le Toine. And Thuy, I am absolutely so happy that you've been able to come and talk to us. Thuy, before we talk about anything else, you must be absolutely delighted.
Okay, I feel so happy, and it's beyond words to see Biomass lift off.
And Thuy, I just realised that the mic wasn't switched on, so let's just start again. I just was saying you must be absolutely over the moon.
Yeah, I feel so happy, and we beyond words to see Biomass lift off and now reaching its orbit. And I feel like people at the end of a long journey. Yeah. But it's not the end of the story, because it is the beginning of an exciting phase when the Biomass will deliver
Pilotage calme de l'étage à Boom, les pressions sont nominaux.
The community will take in charge the data and transform them to useful information and making use of it. Yeah,
absolutely. And it's not the end at all. I mean, it's the end for some, but very much the beginning now of Biomass's life, your new baby. It's in space. going through its early stages before it can start its job. That will be in about 6 months' time, won't it? The commissioning phase takes about 6 months before it's ready. Listen, I tell you what, I thought might be interesting to ask you, before we talk about the satellite itself. The satellite's called Biomass.
Yeah.
But what actually is biomass, the organic matter?
Normally, the name should be forest satellite, for example. Yeah. But biomass is because we focus on the carbon content of the forest. Biomass is a proxy of carbon content. About 50% of biomass is carbon. Yeah. And why it's so important? Because it's the dry mass of the organic matters in the wood. And plants, as you have seen before, the plants absorb carbon dioxide from the atmosphere and transform it through photosynthesis into convert it into biomass. So the biomass is then a key information in the global carbon cycle, because the biomass density, which is the quantity of biomass per area, like we express it in tons per hectare or megagram per hectare. This density determines the amount of carbon emitted to the atmosphere by the forest when they are disturbed through burning, decay, degradation, etc. And then as the trees grow, they absorb atmospheric carbon, and then they increase the biomass. So we call we talk about the role of forest as a carbon sink to take over the.
Yes.
Yeah.
And how much of a problem is this? I mean, as you say, we've often
Pression
hear about
nominale dans l'étage
the
avant.
forests actually emitting carbon dioxide rather than absorbing it. How much of a problem
Fin de
is
la manœuvre
that?
d'orientation de l'étage avant en vue de sa passivation.
I'm just letting everybody know that the range operations manager is still calling
Perte
out
attendue de la télémesure.
the various events, because of course the rocket itself is still going through its process.
Yes, okay. We know very little about what is the current status
d'environ
and the
31
prediction
minutes
for
et
the
12
future.
secondes.
Yeah, but measurement on the ground show that the forest in Africa can increase its carbon absorption, but decline elsewhere, like in Amazonia, like here. The forest seem to have a less and less capacity to absorb carbon. And so what happens if the carbon sink will not be there to absorb what we emit to the atmosphere? And so the CO2 will stay in the atmosphere, and with very big consequences on our climate. Yeah. So it's very important to know the present status of the forest and to predict with reasonable precision what is the future of that, the future of the carbon sinks.
Yeah, it is. It's hugely important. It's hugely important for all of us. I know. Yesterday, Thuy, you did something really lovely. You went into the forest because, of course, one of the forests that Thuy and your teams and all the scientists are studying is obviously the Amazon rainforest and the equatorial forests and the tropical forests around the Earth. And I think I'm right in saying that one of the very important research stations is actually here, only 45 minutes from the spaceport in the Amazon rainforest. What's it called?
Parakou.
Here, look,
station.
we can see you.
Okay.
What were you doing here?
Okay, so this is a long story. When we want to design the mission, and we need to know about a lot of information about the forest and how we can do the measurement, or what kind of acquisition mode we can develop design, and also the algorithm to transform the data into biomass, height, etc. And then we need to understand a lot about the forest. So we went to the forest. The first forest I went to is in Kourou, here in French Guiana. And then I saw a very big plot, research plot. In total, they have 16 plots of 120 hectares. Of the biggest site is 500 by 500 meters. The smaller site is 250 to 250 meters. And they are doing measurement of each of the trees every year, every 2 years or 5 years. It's incredible work. And so this kind of data, we need to calibrate our methods and to validate our results.
So you're going to be using the information from the satellite to supplement and to fill the fill the gaps, if you like, in data that you need.
The first thing is, until now, people used to do to have inventory on such kind of plot, but in the tropic they are very few. And how to extrapolate, you see, the result of the data from the research plot to the vast area of tropical forest. Or we need to have a lot of them, or we need a way like a satellite to extrapolate what we learn locally to regionally and globally. Yeah.
So just very briefly, before we leave you, because we're going to go to hopefully go over now to the European Space Operations Centre. Thuy, and you actually came up with the idea, didn't you, of the biomass satellite about 20 years ago? Just briefly, Thuy.
Yeah, it's more than that, because it was at the beginning an experiment opportunity when an aircraft equipped with radar fly over, and I have seen that.
And you had the idea, and I'm going to stop you because we are going to go hopefully now to the European Space Operations Centre. Thuy, thank you so very much. Everyone told her it wasn't going to happen, but it did, and
I
here we
can
are.
say hello to all my colleagues.
I'm going to stop you because we're going over now to the European Space Operations Centre and Thomas Ormiston. Over to you, Thomas.
Okay, thank you.
Thank you, Thuy.
Hello, thank you, Katie, and welcome back, everybody, to Mission Control here in Darmstadt, Germany. We've moved out of the control room now because our job is about to start here. But of course, you can see on your screens there the views of the flight control team that are getting ready to control biomass, to fly biomass. What's been happening over the last 10 minutes or so since you saw separation is that the spacecraft has gone down from Australia, where it separated, come under the South Pole of the Earth, and is coming back up towards the Atlantic now. And we have a station, a ground station. That's a big dish that we're going to use to receive the signal in Troll. That's in Antarctica. And it's currently sitting, pointing at the horizon, waiting for biomass to rise. And that's the point at which we will hopefully catch the signal from biomass. And, of course, not just the signal, but that all-important data of the spacecraft telling us how it's doing, that it's safe, that it's happy, that it's healthy. And that's exactly what we're looking for and waiting for now. The team is getting ready to see that data. What they'll be doing as soon as that data comes in is checking the health of the spacecraft. So, of course, they won't be jumping up and down and cheering. Don't worry if they don't do that, because our job here at ESOC starts at the very moment where we see that signal. So I think we're going to listen in now to the control room.
Acquisition de la télémesure Biomass.
So we've received the signal in Kourou, and we're just waiting now for that confirmation from our flight director, Jose Morales, here at ESOC. Okay, yes, and we're looking on the screen there for the signal. We can't quite see the spike in that wobbly line, but that's not the only information that we have. Of course, our displays are lighting up green as well, which is good news that we are catching the data from Biomass. The teams are, of course, now very, very hard at work, and we may listen just a little bit longer to see if we get a message from Jose Morales, the flight director, or possibly he's too excited by the telemetry that's coming in now. So let's listen just a couple of seconds longer. Okay, so indeed, I think we're not going to hear from the flight director right now. I think we can forgive him that. Of course, this is a very exciting moment. Our screens there are lighting up with data from the Biomass spacecraft. We have a new spacecraft and the teams are now hard at work. There was some quick thumbs up before they had to get their heads down and start looking at the consoles, looking at that data, and right now they will be checking out Biomass and welcoming it to its new home in space. But here in the briefing room, this is our room next to the control room, I am very lucky to have Klaus Skipal, the mission manager for Biomass, with me. And Klaus, you have a new baby in space. How are you feeling?
Super excited. You said you won't see the excitement here in the room maybe, but I would like to jump up and down. It's of course seeing the launch an hour ago was already super exciting, seeing that everything goes smoothly, that we get our orbit very nicely. But now getting the first signal is of course a big relief, even if everything is planned and is trained and practiced, so you expect this to happen, but still I think it's a big relief for the whole team that you hear the satellite for the first time.
Absolutely, no, it's a big moment for us all, but of course the first signal isn't everything. I say the team are hard at work now just in the next few minutes, but of the next hours and days and months there's still a lot coming. What is next? What's coming up for Biomass?
So the next steps that we have to take is the LEOP phase, the launch and early orbit phase. Normally this takes for a satellite 2 to 3 days, where we switch on all the instruments on board, all the systems, so we check everything is okay. For Biomass it's a bit special, it will take a bit longer, and this has to do with the special shape of the satellite or with the special structure of the satellite. We have this big umbrella that sits still on the back of the satellite. It's folded like an umbrella and we have to unfold it. This will go in several steps, so it has 3 arms that unfold with time. It starts to wobble at each step, so we have to wait until it stabilizes again, and then we can bloom the satellite so we can unfold this umbrella, which will be the next big thing to see. And then comes the first image. Then we can switch on the instrument. In about 3 to 4 weeks we will get the first image, and I think this will then be the real big step for us, seeing the first time the Earth at P-band from space. It's also for all the scientists. I think everyone is waiting for this since 20 years now.
Wow, no, it's going to be really fantastic. And I mean, yeah, as the mission manager, what are your personal expectations for the success of this mission?
Of course, with the mission, our big goal is to determine how much carbon is stored in the forest globally. This will be what we are measured against at the end. But for me, having the first time in space at P-band SAR, I think every step we take now is already a big success. So having the signal now was already a big success and real relief. Getting the first image will be the next success, and then taking routine observations. I think this will be with every image we will get in. It will be a success. People will discover new things, and we'll get excited about this mission.
Fantastic, yeah. And I mean, the people that will get excited, I mean, who will be the main users of Biomass data? I mean, I assume primarily scientists, but could the data have an even further reach to policymakers or beyond?
Of course, it's an Earth Explorer. It's the first time we have a P-band in space, so there's a lot of scientists involved, and at the beginning our main community will be the scientific community, and that's the main purpose of the mission. But because forests are so important in the global carbon cycle, there's a whole market currently building up around this. We give incentives to countries to protect their forests, for example. And of course, people want to control this, and there's companies who are offering these services. And of course, they're very interested in this mission. It will take some time. I don't think we will do this from the first day of the mission, so we will take some years. But we're already talking to these people and preparing them for this mission. I'm pretty sure at the end of the mission, they will use this data.
Exciting, yeah, no, it's really exciting what the reach of this data is going to be. But of course, I mean, we didn't just arrive here today. This mission has been a long time in preparation. It's a big project, and it must have been a challenge just to get here. Can you tell us something about how the teams, of course, have overcome that and got to where we are today?
So as every satellite we build, especially Earth Explorers, because they are so new, we build new technologies. It's a long journey. So we started, I think the first proposal we get 20 years ago, 2005, and you saw some of the scientists behind this mission just on the screen. Some of them even retired by now. So to keep this team up and to go 20 years is, of course, a challenge in itself. But I think everyone was so excited about this mission, so it was not a big issue. On the way, of course, you face a lot of engineering challenges. We build a lot of the things we have on board were first of its kind technologies that had to be built. The reflector we have here, I think we never had a reflector this size in Europe. I think it's the first reflector ever that we do in Europe. It's the first P-band SAR, which is, of course, posing a lot of issues, starting with the requirements at the beginning. You have to build something which you do not really know. You have to start to explore with little data sets that you collect here and there. So these are all challenges you face. These are typical engineering challenges, which I think at the agency and at the industry we are well prepared to take. We are equipped for doing this job. But then on top of that, there come other challenges. We have developed this satellite at the height of the COVID crisis. If you take, we were 50 companies involved, spread over 20 countries, 700 people at the peak of the development time, and then you're in lockdown. You cannot communicate, you cannot test as you planned. But everything, I think, at the end went very smoothly, and we got there, and now everyone is excited.
Yeah,
all problems are forgotten.
Oh yes. Hopefully we won't find too many new ones, but of course the control team here is ready for the challenges. And I mean, that's the next question from me is, I mean, the challenges don't stop at launch. I mean, challenges or excitements maybe don't stop at launch. I mean, what sort of things do you expect to be challenging, difficult, interesting during the operations phase of the mission? I guess there's some special tricks you're going to need to do to acquire this data, to process this data, to make it usable.
So one of the big challenges of this satellite is, of course, to acquire global images. It was mentioned previously that we have to change our orbits all the time. So it's a mission that is permanently in move. And this, of course, poses a lot of challenges for the operation teams. We also need a very tight orbit control. We want to do interferometry that only works if you know your orbit very precisely. So maintaining this orbit and changing the orbit every 3 days, rolling the satellite, this is a big challenge, of course. The other challenge is, of course, we need to calibrate the satellite. The satellite is so big that it didn't fit into any test facilities we have on ground, so we could never test the satellite end-to-end with the unfolded antenna and with all the instruments on. So this is something we can only do in orbit, which is, of course, something we have never done before either. So normally we test everything on ground before we send it up. And this will be a big challenge, of course, to calibrate it, to make sure over the lifetime of this 5-year mission, we maintain a stable signal so that scientists can really start working with this and can really trust the data we deliver. And then, of course, the biggest challenge for us is first time we look at the Earth at P-band, first time we observe a lot of phenomenon. We have collected a few airborne data sets with an instrument very similar to that, but it was only snapshots, and now we get real data in. And we will learn with every image that comes in. We will learn. We know a lot, but I think there's also a lot of unknowns that we face and that we will need to deal with as they come.
Absolutely. No, thank you ever so much. Yeah, the unknowns they can be exciting, they can be terrifying. We mentioned it earlier that, of course, unknowns here in the control room tend to spook us a little bit, but the team behind me are very well practiced, and I promise you, Klaus, that we will take very good care of your baby for its whole life, flying it here from ESOC. But right now, I think we can hear from some more people in Kourou, so we'll let the teams work. Stay in touch on ESA's channels to find out more about what the Biomass mission is doing. But for now, back over to you, Katie, in Kourou.
Thank you very much indeed, Thomas and Klaus. Great to hear all of that, and great congratulations now as you take on your new baby. So let's hear now from the various directors of organisations involved. We have with us Simonetta Kelly, who's the Director of Earth Observation at the European Space Agency, Tony Tolka-Nielsen, who is the Director of Space Transportation at ESA, Giulio Ranzo, who is the Chief Executive Officer of Avio, and we have Mark Steckling, who is the Head of Earth Observation, Science and Exploration at Airbus, who are the manufacturers of the satellite. Simonetta, let's start with you. You and your colleagues at the European Space Agency and in Earth Observation, you must be absolutely delighted now that you've got this satellite in space.
Thank you, Kathy. We are extremely thrilled, delighted, emotional of this fantastic, successful launch. Biomass is a great mission. We heard all about it. It's a mission which serves citizens, health, science, innovation. It's an Earth Explorer. It's part of FutureEO. 20 member states of ESA have contributed to that. So really thank you for the support we got from member states. We worked with Canada and the US on this mission. And about 50 companies all over Europe, 700 engineers, worked on the development, and Airbus UK with Airbus Germany building the instrument. This new radar, P-band radar, which is really a fantastic instrument to look at tropical forest, 3D vision of the carbon fluxes on all what we need to know. But now we're going to go to also thank you to the teams. In fact, the project teams did a fabulous job, and also ESOC now that's taking over with the layup operation the coming months and all the verification of the instruments and the validation. Last but not least, I'd like to really thank the whole scientific community, because there was a great preparation of this mission by the science community. There are great expectations to support the climate variables that we need to monitor with biomass. We need to know more about the state of our planet overall, and this mission is really at the core of that. Just yesterday in French Guiana, we have 2 calibration validation sites of that mission, and a lot of work will be done through 100 validation sites all over the world for a project called GeoTrees. So big thank you to all these collaborations, and this is quite unique in Europe. I must say thank you also to Arianespace, of course, to Avio, for delivering the satellite into the right orbit, which is essential. Thanks a lot.
Indeed. And let's go now to Tony Tolka-Nielsen. Tony, the Director of Space Transportation at the European Space Agency. Tony, it's a very important day, isn't it, for European access to space?
Sorry, yes, absolutely, Kathy. And it's a great day to be a Director of Space Transportation, especially in this moment. The mission I happen to know very well because of my history, and I knew how important this mission was. And it's, of course, very, very special to have an ESA satellite, very important one, a scientific Earth Explorer, and an ESA launcher operated by an ESA Space Satellite Operations Center in ESOC. So a very special day for ESA. And this was the first flight of Vega-C after the return to flight. And Vega is back and really consolidated. We have also done 2 flights with Ariane 6, and we will say we are back with space transportation and access to space, and this is great, and exactly this mission indicates and demonstrates how important Europe's access to space is, and we have now restored this, and we are ready and ramping up both Vega-C and Ariane 6. So, but for now, really great with this Biomass mission, which is a great mission. And I wish all the best for this satellite. Thank you.
And Giulio Ranzo, you're the Chief Executive Officer of Avio. Avio, the company, of course, who built the rocket, the Vega-C rocket. She performed flawlessly today, didn't she?
It seems so. So the Vega-C launcher performed accurately, as it has done also over the last flight for Sentinel-1C. It seems a very accurate orbital injection, which is a very important feature for a rocket, and it has consolidated very well, as Tony was saying, the capability of Vega-C to launch to space the most important Earth observation missions for Europe, not only for the European Commission, but also for the European Space Agency and for other European agencies. So I wish we will have so many other missions for Earth observation. This is so important for our planet to observe what we do, but this could not be done without a rocket that delivers accurately the satellites to space. And for this reason, I'd like to pay a particular tribute to my team at Avio for a very, very good job at integrating this rocket. Imagine this is a machine made of 30,000 parts, all of which need to work flawlessly throughout the flight and receive very relevant shocks. They have done a phenomenal job, and I could not be more proud, and I ask you to pay one big applause to these people who are sitting here. Thank you.
And Mark Steckling, Mark, congratulations to everybody at Airbus for building such a remarkable satellite. I think everyone must be feeling very proud.
Kati, thank you very much. I'm still very excited of this morning's launch. It was certainly one for the history books, and I'm very proud that the golden age of biomass has just started. But I would like to underline as well that that success would not have been possible without our teams, without their engagement, dedication and hard work. And as you know, it took us 9 years to deliver that satellite, and now it is in orbit. A big thank you to ESA. A big thank you certainly to Avio and to Arianespace in order to put that satellite successfully in orbit. The interesting part is now going to start. We are starting the commissioning phase, and then the official handover is by end of the year. So the only remaining word I would like to say to Biomass, go, go, go. Thank you very much.
And thank you all very much. And what a fantastic collaboration of teamwork. Well, we're at the end of our program now. It's mission accomplished so far. Congratulations to everybody and all the teams at the European Space Operations Centre as you fly your satellites now.
Yeah, congratulations to everyone. For many people, at the end of a story, and for others, it's the beginning of a new chapter, as we mentioned. So yeah, good luck for the next steps, and go Biomass. Yeah.
Yeah, absolutely. Stay tuned for the press conference. That's in about half an hour, and that takes place at 8:15 here in Kourou. That's 12:15 Universal Time and 1:15 in Europe. But for now, from Samuel Rogers.
And from Katie as well.
Bye-bye.
Goodbye.